Chapter 4 audio lectures. So in the first part we looked at the epithelial tissue. Now we're going to look at the connective tissue, and then the last part's going to be super short because we just have to cover the muscles and the neurological system. Okay, so the first two parts, epithelial and the connective tissue, those are the ones that have a bunch of subcategories and a bunch of different types. So again, those are the ones that you want to really focus on, and especially for the labeling, for like the lab practical, you want to make sure you have those done and you can sort of pick out which ones are which. Okay, so really focus on the photos and making sure you know the exact type of tissue that you're kind of looking at. And really, you cannot practice it too much. Okay. So let's take a look at connective tissue here. So it's the most abundant and widely distributed tissue in the body. Always a good multiple choice question, right? What's the most abundant? What's the most widely distributed? So you want to definitely highlight that. You have four main classes. You have connective tissue proper, which is probably the one that we kind of think about most of the time. You're also going to have cartilage is going to be considered a connective tissue. You have bone and you have blood. And again, for labeling, you want to make sure you have to specify that it's connective tissue. Okay, so if you get a slide or you get a picture where it shows a picture of blood and you just put blood, you're only going to get 1 point. You want to make sure you put blood, connective tissue, bone, connective tissue. And this is one where people kind of forget to kind of put the connective tissue part. Okay, so but any slide you see, you want to make sure you're specifying which of the four main types of tissues that you're sort of looking at, and then specify the exact type. But we'll we have some practice slides that we'll look at where we'll make sure we're all on the same page. So the major functions of connective tissue are going to be binding and supporting, protecting, insulating, storing reserve fuel, transporting substances within the body. And again, because when you look at this one, you see that there's some things that we might not necessarily consider connective tissue, or we didn't know that they were connective tissue. We're going to end up with a few different functions. Okay, so binding, supporting, protecting, those are the ones we're familiar with. So that's my bone, my cartilage. Insulating is going to be my adipose or my fat tissue, right? Form a connective tissue, so we get all those functions. Storing reserve fuel is going to be the fat, and then transporting substances within the body. We use our blood to get things all over to all the different tissues in our body, so we're going to use that blood, but again, it's going to give you some functions for connective tissue that we might not think of on a regular basis. So just keep those in mind because those can be a little bit tricky too. So common characteristics of connective tissue, or how do things end up being named connective tissue? There are three characteristics that make connective tissue different from other tissues. Again, good multiple choice question. They have common origin. They have varying degrees of vascularity. So again, anytime you see vascular, you want to start thinking about blood flow and how do they get their nutrients. They're also going to have what's called an extracellular matrix, and we're going to take a look at that in a second here too. Okay, but common origin means they all arise from mesenchyme or from embryonic tissue. Degrees of vascularity. Some are going to be avascular, which means they do not have their own blood supply. Some are going to be richly supplied with blood. They're also going to have this extracellular matrix. They're going to have wide spaces separating living cells of tissue. It's going to allow the connective tissue to sort of bear weight. It's going to allow it to withstand tension, endure abuse, physical trauma. And again, my cartilage and my connective tissue, it can basically tolerate more things than any other tissue can in the body. Okay, so more than any other tissue can tolerate, your connective tissue is going to be really good at doing all these different things for us. So now we go to the structural elements of connective tissue. You're going to have three main elements. Okay, you're going to have the ground substance. Again, we're going to look at that in a second. You're going to have fibers and you're going to have cells. And it's basically going to be, the ground substance and the fibers are going to make up this extracellular matrix for me. And again, we'll see a picture here in a second. But the composition and the arrangement are going to vary widely. And this is going to be what accounts for this amazing diversity. Okay, so in amazing kind of different functions that the connective tissue is going to play kind of within our body. So it's going to give it the ability to perform many specific functions. And it's going to really be based on the amount of cells and the type of cells and the amount of fibers and the type of fibers that are in there. Okay, so here's our picture, and again, it's always good to have a picture, but I get this extracellular matrix, okay, and I get this ground substance, and I can see that I have all these different little fibers in here, and I can also see that I have a bunch of other kind of cells in there. So we're going to look at exactly sort of what these things are made up of, and sort of what their main functions are going to kind of be. But come back to this picture, because again, you want to just be able to sort of have that visual image when you're figuring all this stuff out and kind of being able to label and sort of see what the job of each thing of these things is going to be. Okay, so what exactly is ground substance? Okay, so it's unstructured material that fills the space between the cells and contains my fibers. Okay, it's the medium in which nutrients and other dissolved substances can diffuse between the blood capillaries and the cells. So it's basically the thing that all these fibers and all these cells are kind of sitting in, okay? So connective tissue fibers, we're going to have fibers, which are proteins. They're going to provide support. We have three types of fibers that are found in the connective tissue matrix. We're going to have collagen fibers, elastic fibers, reticular fibers. They're all going to be a little bit different. So my collagen fibers are going to be composed of fibrous protein collagen, and you want to think about strength, okay? When you see collagen, they're going to be secreted into the extracellular space. They're going to be assembled into these thick collagen fibers. They're extremely tough, okay? So anytime you hear about collagen fibers, you want to think that they're really strong. They're going to provide high tensile strength, which means that they're going to resist being pulled apart. And these fibers, when they're compared to things in our normal environment, they're going to be stronger than actual steel fibers. Okay, and it's amazing, especially when you go in and look at a cadaver, and you go in and sort of look at tendons, and you look at all these ligaments in the body, and you kind of see how thick and strong they are. It's pretty amazing what your body's kind of able to create. Okay, so these ones are going to be stronger than steel fibers. So now we have elastic fibers. They're going to be long, thin, elastic fibers, kind of like a rubber band, right? So they're going to contain the rubber-like protein elastin. They're going to allow them to stretch, recoil. They can stretch, and again, the important part is that after they're stretched, they can return back to their sort of normal length. And again, I want to think about all these different types of fibers, and I want to start thinking about, okay, collagen's going to be tough, elastic's going to be more stretchy. I want to start thinking about, okay, where would I need these things in the body? Because again, that'll help you to sort of realize, okay, where am I going to find these different types of tissues? Okay, so now we get to the last one, which are our reticular fibers. And anytime you see reticular, you want to think that they're a little more delicate. Okay, so they're going to be fine, mesh-like, short, fine, collagenous fibers. They're going to form these delicate networks. They're going to surround things that are a little more delicate. So surround small blood vessels, support the soft tissue organs. They're going to be particularly abundant where connective tissue is next to other types of tissues. Okay, but think about it as being a little bit more delicate. Okay, so now we have these other cells. Connective tissue cells, so we saw in the picture here. So connective tissue cells exist in immature and mature forms, and we want to start breaking down our terminology where we'll see certain things that repeat throughout all our science classes, okay? And we want to sort of remember those so that it makes it easier for us to figure out the terminology and the different definitions. So anytime you see blast, so fibroblast, chondroblast, osteoblast, it's basically telling you that it's an immature form of the cell, okay? And anytime I see a site, I want to remember that that's going to be a mature cell. And these questions always come up as to what does the immature cell do, what does the mature cell do. So you want to really just don't skip over it. Make sure you focus on it for a little bit. So immature cells are going to secrete the ground substance, okay, and the fibers for their particular matrix. So they're just secreting all those things that kind of make it originally. And then once we synthesize and we sort of make all these things, they're going to turn into these mature cells, and then they're going to help to keep that tissue kind of healthy. Okay, so we get primary blast cell types for connective tissue. You get fibroblasts. They're going to be immature again, but this is for my connective tissue proper. We're going to get chondroblasts. They're going to be for our cartilage. Anytime you see chondro, you want to think about cartilage. Osteoblast, osteo is always going to mean bone, okay? And then again, once they synthesize the matrix, they're going to assume this mature form, and they're going to help to just sort of maintain that matrix health for me. So other cells in the connective tissue, and again, we saw this in the picture, but we have fat cells in there. They're going to store nutrients for us. White cells, mast cells. Again, anytime you see white cell, mast cell, you want to start thinking about our immunity and sort of keeping things healthy. But I want to have just a general understanding of what the basic function of these are going to be. So white blood cells, tissue response to injury. These are my neutrophils, eosinophils, lymphocytes. You'll do a whole chapter on that in part 2. Mast cells are going to detect bacteria, fungi. They're going to initiate this inflammatory response. Okay, so heparin is going to be for blood clotting. Histamine is going to be for allergies. And then we have macrophages. So macrophage is large and phages is eating. So they're going to devour a variety of foreign materials. So bacteria, dust particles, dead tissue cells. Very active in the immune system. So again, these cells are going to be in there just to, again, keep everything healthy, keep everything functioning to the best of its ability, help us to maintain that homeostasis that we talked about in the earlier chapters. So now we get to our main actual types of connective tissue. And again, it's going to all reflect the cell types that are included, and then the fiber types and the amounts of all these things are going to determine how they're going to be a little bit different and how they're going to perform these different kind of functions for me, okay? But this is where we want to make sure we can kind of label things and identify it as what it's going to be. So you want to be able to label the image as the proper type of tissue, and then I want to know sort of the main function and just where it's going to be found in the body, because again, those are good labeling questions, but also good lecture questions too. So connective tissue proper includes all mature connective tissue except bone, cartilage, and blood. Again, this is a really good question too for multiple choice. You know, which one of these is not included in connective tissue proper? So remember that bone, cartilage, blood, not part of this connective tissue proper. We're going to get two subclasses. We're going to get loose connective tissue, and we're going to get dense connective tissue. And again, I want to make sure I know the subcategories. You know, make sure for connective tissue proper, I know that there's loose and dense, and then we're going to get some subcategories for the loose and the dense, and then we'll move on to the cartilage and the blood and the bone. So here is my loose connective tissue types, and again, I want to make sure I know that areolar, adipose, and reticular are types of loose connective tissue, okay? And again, some of them make more sense, but again, we'll look at the pictures and we'll sort of look at how do we know and sort of what, what do they have in common here. So loose areolar connective tissue, the most obvious structural feature, and again, if we were looking at this under the microscope, it'd be really, really easy to identify, is that it's going to have this loose arrangement of fibers. The rest of the matrix is going to appear to be empty space, so there's going to be a lot of open space. So areolar actually means small open space. And all of the loose types of connective tissue are going to have this more open areas, and all the ones that are a little more dense are going to have a lot more fibers in there. Okay, so the loose nature provides a reservoir of water, salts for the surrounding body tissues, provides a space for cells to obtain nutrients from and to release their waste into, and we're going to look at some pictures here too. But this one's going to be the most widely distributed connective tissue in the body. Again, very, really important question. Serves as packing material between tissues. It's going to bind body parts together, but allows them to move freely over one another. It's going to wrap small blood vessels, nerves, glands. It's going to cushion, attaches the skin to underlying structures. And again, when we talked about the epithelial tissue, and we're going to do a whole chapter on the skin, we said, that epithelial tissue is going to rest on connective tissue and get all its nutrients from connective tissue. This is the type of connective tissue that it's going to rest upon, okay? So it's really, that's why it's so common in the body, is that all this epithelial tissue is going to rest on this type of tissue. So here is our picture. And again, this is one that I want to really make sure that when I see this, I know, hey, loose areolar connective tissue. That's how you get the full points. And again, when I look at this, I can see the fibers again, okay, and I can see the other cells, but I do get all this kind of open space here, okay? And that's going to let you know that it's loose rather than being more dense, okay? And you're going to see that kind of in the ones that we look at in the next little bit here too, okay? And this is just a good summary of what does it do for me, what's the proper name, and then where is it going to be located in the body, okay? But look for those open spaces because I know that that's going to be my loose connective tissue. So now we move on to adipose, or fat, similar in structure and function to areolar tissue, much greater nutrient storing ability. The adipose, or the fat cells, are going to account for 90% of the mass. Cells packed closely together, very little matrix. You're going to see that in a picture here too. Oil droplet occupies most of the fat cells. This is the one that everybody kind of hopes shows up on your test because it's really easy to identify. It's going to push that nucleus to one side. It's going to be richly vascularized, indicating its high metabolic activity. Okay, so adipose develops almost anywhere that areolar tissue is plentiful. It's going to make up approximately 18% of the average person's body weight. A lot of us already know sort of what the functions are. We know it's for storing energy. We know it's going to help keep us warm, going to act as a shock absorber. Fat beneath your skin is going to serve the general nutrient needs of the entire body. And again, everyone sort of builds up fat in different areas. Smaller deposits of fat will serve local nutrient needs of highly active organs. So sometimes your organs are going to have these deposits of fat that are going to be just more specifically for them to sort of have nutrients available to them. Okay, so your heart, your lymph nodes, and some muscles will sort of have their own smaller deposits of fat. So here's our picture of our fat, and again, we want to be adipose, but if you just put adipose, you're going to lose 1 point. You got to put adipose, and you got to put loose connective tissue, okay? I don't need the connective tissue proper, but I need you to give me the loose connective tissue adipose when you get this slide on your exam, okay? And again, you can see where it's the adipose cell, and it sort of pushes that nucleus sort of over to the side. Now we get to the reticular connective tissue. So it also resembles areolar connective tissue. Only fibers in its matrix are reticular fibers. Again, delicate is what you want to think about when you see these ones. So delicate network along which fibroblasts are scattered, support free blood cells in lymph nodes, spleen, bone marrow. And again, I get this picture here where I can see these open spaces. Okay, so that kind of tells me, again, it's connective tissue, but it's going to be a loose type. And then I get my reticular one. And again, you want to just really like take these pictures, take a picture from your book, put these on your phone. You want to just be able to kind of flip through them and just make sure that, you know, when this comes up, I know it's loose, connective tissue, reticular. So now we get to the dense type, okay? And the main thing with the dense type is they're not going to have the open space. They're going to have just more fibers in there, okay? But we get three different varieties. We get dense regular, we get dense irregular, and then we get elastic, okay? Usually called fibrous connective tissues. And again, fibers are going to be the predominant element instead of with the loose ones where we have more space kind of in there. So dense regular connective tissue, and I'm going to point out one thing that I want you to really pay attention to, but it closely packed bundles of collagen fibers, so we know they're going to be really strong. And the important thing to remember with the regular ones is that the fibers are all going to run in the same direction, okay? So they're going to be very good at responding to forces, but only in one direction. So the arrangement results in a flexible structure with great resistance to tension or pulling forces exerted in a single direction, okay, but not good at responding to things coming in different directions. So limited ground substance, few other cells. The fibers are going to be slightly wavy, which we'll see in a picture, and again, they're going to be poorly vascularized. And again, when you see poorly vascularized, you just want to instantly think like, okay, this is going to heal poorly, okay, because that, you know, a lot of the way our body heals is through this blood flow. So if something is poorly vascularized, it means it's going to not heal as well as something that's going to be highly vascularized, okay? So dense regular connective tissue, and again, it's forces in one direction. This is going to make up our tendons, right, which are going to connect muscles to bones. Going to make up our ligaments, connecting a bone to another bone. It's going to create our fascia, and it's going to create our aponeuroses. It's basically just a flat tendon. But again, it's things that muscles are only pulling in one direction. Ligaments are meant to resist forces in one direction. Okay, so if you apply forces in different directions, we're going to have some issues with these. Okay, but this is usually when we're talking about connective tissue. These are the things that we're probably thinking about. So remember, dense regular connective tissue, ligaments, tendons, fascia, aponeurosis. Okay, so here's a picture of our muscle, and again, good time to just be like, okay, what's the difference between a ligament and a tendon? Tendon is a muscle to a bone. Ligament is a bone to a bone. So if you sprain your ankle, if you strain a muscle, you want to make sure you're using that proper terminology. So when I sprain my ankle, that's a ligament injury. When I strain my hamstring, it's going to be more my muscle and my tendon. So now we get to our picture of our dense connective tissue, and again we can see where it's mostly fibers, and they're wavy, but they're running in one direction, and again different from the loose because there's just not so many fibers kind of in there, or not so much open space in there. Okay, lots of fibers. So now we get to the dense irregular, and again this one's going to be similar but a little bit different because these fibers are going to be arranged irregularly, and they're going to be arranged in more than one plane. Okay, so same structural elements as regular connective tissue. You get bundles of collagen fibers. They're going to be much thicker, again, arranged irregularly. They can respond to things in more than one plane. They're going to form sheets in areas where tension is exerted in different directions, and instantaneously I want to think about, okay, where am I going to need this? And where you're going to need this is in your fibrous kind of joint capsules, and we'll look at a picture of the knee here too. So fibrous coverings that surround some organs, kidneys, bones, cartilage, muscles, and nerves. Okay, and we look at this one where we're looking at the knee here. Soccer players especially, you're always stopping, starting, changing direction, moving in different directions, speeding up, slowing down, a lot of forces from all these different little directions, and that's why the fibers cannot be just arranged in one sort of way, because again, then I would have this just very unstable joint. So I need something that's made a little differently where I can respond to forces in a bunch of different directions. So here's my picture of dense connective tissue, but again, it's a little more orientated in different directions, so it's dense irregular, okay? So now we get to our elastic connective tissue, contain a high proportion of elastic fibers. So this one's going to form ligaments connecting my vertebrae, found in the walls of arteries. And again, I want to think of elastic, and I want to think, okay, it's going to be a lot more stretchy. Again, where am I going to need these sort of things? So walls of large arteries can be high in elasticity. Okay, and here's my picture, and this one's nice because it looks kind of exactly like we would kind of think it was going to look. Okay, it kind of looks like an elastic, but lots of fibers, no space, so I know that it's going to be dense connective tissue, and again, it looks very elastic, so this one's pretty easy to remember too. And again, try not to just memorize like, okay, hey, this is where it said this was going to be. Again, try to go back and just kind of think about, okay, where am I going to need this elasticity? Because most times you're going to be able to figure it out and you're going to be right. And it'll make it where you'll remember. So now we get to cartilage. Okay, so we did our connective tissue proper. Now we're moving into cartilage, and then we'll look at bone, and then we'll look at the blood. Cartilage is another really, really important one. It's going to stand up to both tension and compression. It's going to be the quality of it is going to be between dense connective tissue and bone. It's going to be tough but flexible. It's going to lack nerve fibers. Okay, it's going to be avascular, and this is really, really important too. And we're going to come back to this when we start looking at the bones and we start talking about arthritis. Your cartilage, especially the cartilage that surrounds the ends of your bones, it's not sensitive. It doesn't have those nerve fibers because what it's doing is it's covering up the bones that are really, really sensitive. Okay, but one of the problems we run into with our cartilage is that it's avascular, which means, again, it does not have its own blood supply, which means it's hard to sort of repair it. It's hard to get nutrients in there when you're not using it sort of properly. So it's going to receive nutrients from underlying blood vessels in the surrounding connective tissue. And again, we're going to look at, when we get to the bones and we start looking at injuries a little bit, we're going to come back and sort of look at arthritis and exactly what's kind of going on with arthritis. But what it is, it's this wearing away of the cartilage on the ends of those bones. Okay, so cartilage matrix contains lots of fluid, but it's quite firm. It's going to enable cartilage to rebound after compression, and it's going to also be this, it's going to provide nutrients, okay? So we get to cartilage, and we want to come back and look at the terminology and the cells. So we have chondroblasts, and again, when you see blasts, you want to think about immature. Chondro, I'm going to think about cartilage. So these are my immature cells. They're going to be predominant in growing cartilage. I'm going to have chondrocytes, mature cartilage cells, found in the cavities called lacuna. That always kind of ends up on your final for some reason, so I would start and highlight that too. And then we have three types of cartilage. We have hyaline, elastic, and fibrocartilage. And again, make sure that you know that, hey, if they're saying, hey, which of these is not a form of cartilage, make sure you know all those subcategories and all those subtypes, because again, those are great multiple choice questions. So you want to sort of be able to take a piece of paper and be like, okay, these are my types of epithelium. These are my types of connective tissue. These are my types of cartilage, and make sure you can put everything in the category and make sure you can list those subtypes, because again, they come up on your questions all the time. And if you don't make yourself write it down, sometimes you think, oh, I'll remember, but it can make it a little bit difficult. Okay, so cartilage, hyaline, elastic, and fibrocartilage, and then we'll look at what are the differences between these three. So types of cartilage. So we get hyaline cartilage, really, really important. Most abundant cartilage in the body. So again, highlight it, start, underline it. Contains a large number of collagen fibers, provides firm support with some pliability. This is why it's so important. It's going to be the type of cartilage that covers the ends of our long bones. Okay, it's going to help us form our joints. This is what allows those bones to move smooth over top of each other. But again, you're mostly covering up the ends of the bones and covering up those sensitive parts of the bones so that they're not pushing and rubbing on each other. And then things are, they're not so painful. So absorbs compression at the joints, makes up our embryonic skeleton. So we're going to come back to that too in the bone chapter, where we're going to look at, okay, we make this cartilage model, and then we turn everything into bone. Hyaline cartilage is what we're going to use to sort of make this cartilage model. And then this one has a really cool photo. Looks exactly like this under the microscope. But this is the one, again, that we just want to make sure when I see this, I know that, okay, this is my hyaline cartilage. But what else do I have to put? I have to put connective tissue. Okay, so don't forget, sometimes we get, okay, yeah, that's hyaline cartilage, but again, I have to make sure that I list, which of the four main types is it going to be. So don't forget to put hyaline cartilage, connective tissue. And we get to elastic cartilage, nearly identical to hyaline cartilage, contains many more elastic fibers. So again, it's all based on the fiber types and the amount of fibers, and then which types of cells, found where strength and exceptional stretchability are needed. And again, you can think about, okay, where might I need this elastic cartilage? Your external ear is going to be the best example to that, because again, if your ear was made out of something that was much more rigid, every time we banged our head or walked into something or bumped into something, we would damage it really, really badly. Okay, so it's got to have that elasticity just to keep it a little bit healthier. So here is a picture of our elastic cartilage, but again, I have to put, if I want the full points, I have to put elastic cartilage and I have to put connective tissue. Okay, So here is our last one, which is our fibrocartilage. It's an intermediate between hyaline cartilage and dense regular connective tissue. You get rows of chondrocytes, and they're going to alternate with rows of thick collagen fibers. Okay, so dense regular connective tissue. It's compressible and resists tension well, found where strong support and the ability to withstand heavy pressure are going to be required. And this one comes into play for me as a chiropractor all the time, because these are going to make up my intervertebral disc, so the disc between each of my vertebrae and the part that's going to kind of protect my spinal cord. And it's also going to make up the cartilage of your knee or your meniscus, okay, more specifically. So again, I want to just know, make sure I can label it. I want to know where it's found in the body, and I want to know what the basic function is going to kind of be. Okay, so here's a picture of your knee, and you can look at this meniscus here, but it's going to be this extra sort of layer of protection between the bones. Here's my femur lined with hyaline cartilage, okay, tibia, hyaline cartilage, but then right in here I'm going to have this extra fibrocartilage that's going to sort of protect these areas, and then I do the same thing with my vertebrae, okay, so the bones are lined with hyaline cartilage, but then they're going to also have this fibrocartilage that gives them, a little bit more protection and a little bit more, movement. So here is a picture of my fibrocartilage. Again, fibrocartilage, connective tissue for labeling purposes. And this one, a lot of people kind of get this one wrong. So make sure you're familiar with this picture, because a lot of times we mix it up with, some of like the dense connective tissues too. Okay. So this one again, I'm going to basically use the pictures that you have from your textbook or from your manual. So make sure you're really, really familiar with those, because I think that just makes it, a little more fair. But fibrocartilage, intervertebral discs, meniscus in my knee, okay? And then we move on to bone. This is another one that everybody kind of hopes ends up on your practical exams because it's so distinctive. It's going to be osseous tissue. So anytime you see osseous, you want to think about bone. It's going to be rock-like. You'd be amazed, especially if we were in the lab where we actually have, you guys have these cases of bones, of actual bones from cadavers that you can sort of look at and find all the landmarks. But it's pretty cool to just see how strong they are, okay? So it has the exceptional ability to support and protect body structures. So a lot of our bones we're going to use them for sort of locomotion, but we're going to use them a lot for protection too. So it provides cavities also for storing fat and synthesizing blood cells. We're going to do a whole chapter, a couple chapters really, on the bones. The matrix is similar to cartilage, but it's going to have much more collagen fibers. So again, it just comes down to the amount and the types of fibers. The matrix is also going to contain these inorganic calcium salts, and we're going to use these to sort of harden the bone and make it even tougher. Okay, so again, we get certain types of cells. So osteoblasts, osteo is bone, blast is immature cell, osteocyte, mature cell. We're going to have these structural units. They're going to be called osteons. Again, we'll come back to that in the later chapters, but they're going to form rings of the bony matrix, which are called lamella. Almost like if you've seen someone like cut a tree down and you're sort of looking at the rings. This is what makes it so strong. What you want to remember, though, is like kind of within each of these rings, you're actually going to have a lot of blood vessels and nerves that kind of flow through your bones. And this is kind of why when you do break a bone or you do injure a bone, it's going to be so painful, is because there's a lot of structures in there. A lot of times we just think it's all this connective tissue and all these kind of fibers make it really strong, but there's a lot of things that are kind of moving through there too. Okay, so bones are going to be well supplied with blood vessels, but again, they're going to have blood vessels, nerves, all these things kind of moving through. So here is a picture of our bone under the microscope. Here are our rings, right? Our lamella. But we also get this little central canal, and you want to remember, through this central canal, we're going to have our blood vessels and our nerves kind of moving through there. So here is a picture of, and again, we'll come back to this one when we get into the chapter 6 and chapter 7, but you want to realize that there's a lot of blood vessels in there, and again, this is kind of why it hurts so much when you kind of break these bones. There's a lot more going on in there than we sort of think. Okay, so now we get to the last one, which is our blood. This is one that everybody forgets is a connective tissue, so it's an atypical connective tissue. Classified as connective tissue because it develops from mesenchyme, just like we said, consists of blood cells surrounded by a fluid matrix. So that's the biggest difference, is that it's a fluid matrix. It's called blood plasma. The majority of blood cells are red blood cells. You'll see that in the picture here in a second, but we're also going to have some white blood cells in there. We're going to have some platelets, and again, you can do a lot of different tests to sort of measure the amounts of different types of cells in your blood and kind of see what's going on in your body and how well it's kind of functioning. But it functions as a transport vehicle for nutrients, waste, gases, other substances. Again, you'll go over the blood a lot and sort of the functions of it as you get into part 2 of anatomy and physiology. So here is a picture of our blood. Blood always looks really, really cool under the microscope, and again, I could see the majority of the cells are going to be red blood cells, but I can see that I have some white blood cells in there too. And again, red blood cells are more, carrying oxygen. The white blood cells are more going to deal with your immune system. Okay, so in the last part of the chapter, we're going to move in part 3 of the audio lecture for chapter 4. So we're going to stop here, and again, you want to focus on epithelial, you want to focus on the connective tissue, because you're going to like part 3 because it's pretty short, because we just have to go over 3 types of muscles, and then we just have to take a quick look at the neurological system and what it's going to look like under the microscope too.